Hello, I'm Joana Casado. I'm one of the SonoUno developers, and in this occasion, I am presenting a SonoUno tutorial. SonoUno is a sonification software for astronomical data, and our sponsors are CONICET, ITEDA, IBIO Universidad de Mendoza, and Rainforest. The SonoUno principles are accessibility to scientific data, the creation of a human-computer interface that allows the exploration of the data, to test the software in the different stages of the development, and develop a paradigm for training researchers and interested people to start using this new technique. And SonoUno is an open source and cross-platform software from the beginning. SonoUno presents a modular design. The core module, which one communicates all the other modules, and a dedicated modules for the different principal tasks. The SonoUno framework design began with the decision of what features we want to include in this software. We write each functionality in little pieces of paper, and we decide what are the most important functionality that have to be placed in the principal framework. The other functionality were included in different panels that the user can open and close as they decide. This is a very first approach of the separation of the functionality in different groups, and the final approach of the actual release have 5 groups: the input-output functionalities, the data operation functionality, the settings, the help, and the data display that contain the functionality of the principal framework. Well, now we'll continue with the demonstration. Now we began with the SonoUno tutorial. We open a dataset downloaded from Sloan, a Galaxy. We go to data parameters. We can change the title of the plot and the title of each column. We can use update grid to see the data plotted or original. And we change between different pages to see all the rows of the data. We select best fit as y-axis and close data parameters. Go to slider and mathematical function to cut a little piece of the dataset. Also, we can use the write functionality block to a specific cut in a value. The command is x upper limit and x lower limit. And we can write there play time and give the software a specific time. Right now, the software sometimes don't respect the specific time when it's shorter than the software allows, but it's a higher time rather than the tempo and the only play. We can select different mathematical function that is applied instantaneously to the data. We can cut again and play, mark a point in a specific place, delete the last mark if we have a mistake, stop, and we can save the different things, the data, for example, write the name that we want to give to this new file, and click the save button. The marks is the same process. The sound The software puts the extension of the file automatically after the name that we give to the file and the plot. We select the original data and we save the sound of the original data. The software saves the things that have displayed in the principal framework. This is the data saved, the cut part. This is the one mark that we made. This is the plot. And this is the sound, the short sound. And now this was the larger file. Now we're going to open a new dataset, a glitch, to use the setting functionalities. First, we're going to cut a little the dataset, and then we go to open the configuration panels. We have two parts, the sound and the plot. We're going to play a loop to listen each sound configurations. First the volume. Now set logarithmic scale, linear again, discrete. We can see a frequency mapping limit. Now set the volume mapping. We have a frequency and the limit of the volume, minimum and maximum. We change the frequency of the volume mapping, higher and lower. You just hear a tick mark that indicates the first loop of the play function. Now we're going to change the sound type. First the default is scene, then synth wave, then flute, piano, celesta, and pipe organ. We press stop and select the set frequency mapping again. This part is the sound envelope configuration. Allows to change the envelope that produces the sound. And now we are going to change the plot configurations. Select the grid option, change the color of the line to green, select the point to discrete function, dot and dash line, a solid line again, and we finish with this part of configuration and close the panel of configuration. We can find the configuration in the settings file menu. Then we have the help. Inside about we have a description of the software and the email to contact us, and in the user manual button redirect us to the SonoUno webpage. The SonoUno webpage have a description and for links to the user manual, the instructions, the SonoUno web interface, the gallery, and the GitHub access. In the user manual link, we can find different links to the different part of the SonoUno manual. In each page, we have the next chapter, back to index, and back to home link. It's the user who decides where they want to go. The installation manual page has the buttons to download each version of the installation manuals. To open the web interface, you need a password provided by the group because this is not open access yet. But we want to show you this new approach. They have a quick start part to new users, and the home have the graphic user interface with the input part, the output that the software allows, the same as the desktop version, and a part with sample data. allows to select different ranges, change the tempo, stop, and the same buttons of the desktop version. Present mathematical function. Here, instead of panels, have collapsible buttons that allows to maintain principal framework clean. The sound configuration is basically the same, allows even the envelope configurations. And the plot configuration have the part of the titles, and the advanced plot configuration, the line marker color and the option of the grid. Then we have a help part with the information of the SonoUno, all the manual of the web interface, and the quick start have a summary of the principal things that the software allows to do. About the gallery, for example, we have the glitch that presents the image of the dataset, the plot of the software, the sound, the complete sound, allows to download the full data and shows a little part and download this sample. And the galaxy, on the other hand, have the information, the image, the plot, and the sound. Finally, the GitHub link goes to the repository where is placed the code of the SonoUno desktop and the description, the installation instructive in general, and some lines to open the software. We want to add a little video showing the use of SonoUno with screen readers. In this occasion, we use VoiceOver.
Python, SonoUno, file, menu 4 items, you are screen sharing. Open, dialog. Open data file, open, dialog. You are currently on a text area. File, menu 4 save, submenu 4 items. You are currently on a submenu. To choose this, save sound, save, dialog. Save sound file, save, dialog. Untitled, content select, D. Sound, list 1 item selected. Output, sound, insertion at end of text, sound, sound under O.
Well, right now we finish our demonstration with the actual functionality of the software. But we want to show you what we are working on this year. The next short video shows a sonification of 3 columns at the same time, each one with different sound parameters. Finally, I want to summarize our next steps. First, conclude multi-column sonification. Second, allows more sound features. And third, design a more interactive plot without losing accessibility. I take this opportunity to thank all people that kindly help us during the road. Testing the software and having collaborators to do that is very important to us, to reach our goal and bring all people with different learning styles to the research field. Thanks a lot for your attention. If you want to contact us, you can write an email to sonounoteam@gmail.com. Visit our webpage sonouno.org.r or by our GitHub repository sonounoteam/sonouno. See you on next tutorial. Bye!